Alright, so 1 examples. We will look at the one that you did in your notes in a little bit. I want to do some simpler ones first. So let's just start with something easy. Also, there is an exponent poster over there that has a little bit of the basic rules on it by Berkeley if you happen to forget exponent rules. I don't usually take the poster down, so it'll be there, but hopefully you will know how to do them by the time we have a quiz or a test on them. Alright, so 4 raised to the negative 2 cubed. So based on the rules, what do I have going on here? Okay, meaning what? Okay, multiply the powers, which gives me, so 4 to the negative 6, and what does that mean? Yep, so 1 over 4 to the 6. Normally, I would want you to multiply this stuff out, but since I don't give you a calculator, I will say that it's fine to just leave it like this. Stuff that's like 2 raised to the something, you should be able to do. 3 raised to up to the 4th, you should be able to do. Most of the numbers, I mean, any number squared and probably cubed you should be able to do, but beyond that, you can just leave it like this. Because, I mean, if you have your calculator, like if I give you your calculator, you can use it, but if not, then you can just leave it. So I'm just going to let you guys leave that one like that. Trying to get a variety here. 8, 3 this raised to the 4. So what do we have? Okay, meaning, what do I do? Okay, so 3 to the 4 and 5 to the 4. So what's 3 to the 4th? What's 3 times 3? And so if you have 2 sets of 3 times 3, you have 9 times 9, which is 81 over. This one, I doubt you know 5 to the 4th. Okay, you could multiply 5 times 5 times 5 times 5, which would give you 25 times 25, but I mean, I don't know if you know that off the top of your head or not. Huh? You're really close. Well, I say like you're 100 off, but I know what you're trying to do. Okay, it's technically 625. Okay, you could leave it as 81 over 5 to the 4th. Okay, if you don't know it off the top of your head, that's fine. I'll try to be like lenient if you like Tabitha. Let's just say that you had written 81 over 525. If you have this step, at least I can see like, okay, you just multiplied it wrong, you know, like, and that's fine. Now, if you did like 5 squared wrong, different story. Okay, but something like 5 to the 4th, that's really big, so either of these would be sufficient. Let's see. 10, 9 to the 3rd times 9 to the negative 1. Okay, and just so you know, these instructions do want you to technically write what property you're using, but I don't care about that as long as you can do the problem. Like, you don't need to write which property you're using. So you can just kind of like edit those instructions when you go to do them. Which gives you what? 9 squared, which is 81. Okay, so that one's the easy one. Alright, I want you to do this one on your own. Number 12, 2/3 to the negative 5 times 2/3 to the 4. So try this one on your own. It looks hard, but I promise it's not. Huh? Alright, have we gotten an answer yet? What do we have? Okay. Like you have a negative exponent? Okay, so we haven't talked about that yet, but technically you can't have a negative exponent. Like we'll never have an answer that has a negative exponent. Okay. So Taylor was right. I think some other people said they had that too. Okay. So working in little steps. Okay, the first thing is basically these are the exact same thing. So I don't have to like put the negative 5 on each thing and then put the 4 on each thing. If this is the same number, even if it's a fraction, I can still combine them. Okay, just as if it was a whole number. Okay, so I have 2/3 to the negative 5 plus 4, okay, which is 2/3 to the negative 1. Okay, the negative flips the whole thing over. Okay, so if it's a fraction, it flips it to make it, like, reverse. Okay, if you had, like, 3 raised to the negative 1, you'd have 1 over 3. Okay, because technically every whole number can be written over 1. Yeah. So then, like if, let's just say it was that. So if we had 2/3 to the negative 5th, then basically what you end up doing is you flip it, and then you raise it to the 5th. So yeah, and then obviously 3 to the 5 you don't have to be able to do, though it's probably relatively easy. And then 2 to the 5th would be 32, I think. So if it were that, that's how you would do it. But basically, at negative, just flip it and then apply the exponent that's now positive. Any questions about that? That's something I forgot to mention before. So, okay. Well, 14 is kind of like that, so let's look at that one really quick. 14. We have 1/2 raised to the negative 5th, all raised to the 2. So what does that give us then? Or how would I, or like what's the first step of this one, I guess is what I should say. So that gives me what? Okay, raised to the negative 10. And then what would I need to do because of it being negative? Yeah. Yeah, so it would be 2 to the 10th. Okay, we don't need to write it over 1 because it's a whole number. Okay, if you have a 1 on the bottom, you don't need to write it. So, and then you can just leave that because I'm not going to expect you to multiply out to figure out 2 to the 10th. That we technically would be able to. It'd just be 32 times 32. So, but you can leave it. Nice. Alright, a little bit of scientific notation here, and then we'll go with that. So, did you guys kind of understand what I was talking about with, like, the hint for scientific notation? I know since it was just written, it was probably a little harder to understand, but... Okay, so, like 16, we have 1.2 times 10 to the negative third, and 6.7 times 10 to the negative 7. Okay, you probably won't have your calculator for this, but you should be able to multiply two decimal numbers in reality, but anyways, for the time being, if you want to multiply them with your calculator, that's fine, and then if we get to a test or something and you're like really don't know how to do it by hand, just show that you're multiplying the numbers together. Okay, so what I meant with the hint was basically we're going to take these two numbers and we're going to multiply them together. So 1.2 times 6.7, and then put your little times symbol, and then just do rules of exponents for the 10 to the whatever power. So what would the rules of exponents be? Ignore this other stuff that's here. (10 to the negative 10, because we're adding the exponent, so negative 3 minus 7, so that would be 10 to the negative 10. Okay, and with scientific notation, we don't flip it. We leave it, okay? Like, we don't change negative exponents to be 1 over 10 to the blah, blah, blah. Like, we're not going to do that. So you can either just leave your answer here for now, or if somebody wants to grab their calculator, just for the sake of time, I'm not going to multiply. It's what? Okay. So 8.04 times 10 to the negative 10. Yeah. Anyways. No, because scientific notation is always going to be times 10 raised to some power. Okay, so if it's positive or negative, that tells you what direction the decimal is moving, so you can just leave it. Let's see. 20. 4.0 times 10 to the third raised to the fourth. So what do I have here with this one? So what is that going to give me? Yeah. So yeah, so when it's outside like this, we want to make sure we put it on the whole thing. Okay, we need it on both pieces. And 4 to the fourth, 16 times 16. So if you know what that is, you can do it. If not, you can just leave it like that. Cool. All scientific notation problems, yes. Yeah. And then it'll work the same way, so I'll do like a division one, if you will. So 1.1 times 10 to the negative 3 over 5.5 times 10 to the negative 8. So it still technically works the same way with this one. You're just doing the other rules of exponents. I don't remember what it's called off the top of my head, but anyways. So 1.1 and 5.5, pretty sure that's just 1/5. Yeah, maybe. I don't know. But let's just say it wasn't something even, like that I think that one is an even one, but let's just say it wasn't. You can just leave it like this if you want, because I'm more worried about with these problems with the exponents. So how would I take care of these exponents here? Like, ignore this part. If I just gave you 10 to the negative 3 over 10 to the negative 8, what do I have? So I want to move this one up to the top. So I'm going to add, so to move an exponent from bottom to top, okay, or however you're moving it, you change the sign. Okay, so if it was negative on top, we're adding it to the bottom. If it's negative on the bottom, we're adding it to the top. So this is going to be 10 to the negative 3 plus 8, or 10 to the 5th, then, is what's happening here. Okay, and we always want to move it to the top with the ones that are like fractions like that. Okay, does that make sense? Okay. I'm trying to remember what time we get out of here. 11:05, I think. Well, okay, yes and no. It's the opposite of whatever the sign is. So if I had something like 4.2 times 10 to the 6th over 3.1 times 10 to the 3rd, it's subtracting instead of adding. So it'd be 4.2 over 3.1 times 10 to the 6th minus 3 because this is positive, or this is just going to be 10 to the 3rd. Okay, is what's ultimately happening. Well, you change the sign. So it's like how when you move something from the left to right in an equation, it's the same thing top to bottom. Okay, any questions about scientific notation ones? I know I just did a couple of them, but I feel like they follow the same principles basically, so I want to make sure we're good. Okay, so we can obviously 4 through 14 basically we did with numbers. We can do the same thing with variables. And we want to make sure we're dealing with like terms when we're doing that still. Okay, with numbers it's a little easier to think about because obviously you have the same number, but we need to remember with variables that we're doing the same thing. So, let's see. No, let's start with an easier one. 24. W to the negative 2 over W to the 6th. And as a general rule, I think I kind of said this, but we always want positive exponents. So I want to do whatever I need to do to it to make the exponents be positive. So what do I need to do to this one to give me positive exponents? Okay, so what does that give me then? Okay, so I'm adding this 2 to the bottom, so it's 1 over W to the 8th. Because it's positive 6 on the bottom. So you always want to move it to where it's going to make the exponent be positive. It can be in the denominator, but it has to be positive. So if this were flipped, let's just say this were W to the 2 over W to the negative 6. Okay, what would I do instead? Okay, I'm going to move the 6 up, so that would give me W to the 8th on top. Okay, because I need to get rid of the negative exponent. You don't have to, if it's over 1, you don't have to write the 1. Yeah. And if it were W to the negative 2 over W to the negative 6, what would I do? Okay, but I want to simplify it. So I can do it without having to actually flip them. Okay, yeah, I can still move the 6 to the top. Okay, we always want to move the bigger negative number to the other one. Okay, so W to the negative 2 plus 6 is W to the 4. Okay, So that's just, I know that's kind of a lot in like looking at the same problem, but I'm trying to show you the different cases of what happens in different scenarios there. Well, no, it does matter which one you move because you need a positive exponent in the end. If I moved the 2 down, I would still have w to the negative 4, like 1 over w to the negative 4, and then I would have to go through and flip it. So just saving a step, you can just add the bigger one to the other side, wherever it is. You can try the answer. These ones don't really have a lot of work for them. Yeah, I mean, if you need to, that's fine. And obviously, then if something goes wrong, I see it like, oh, okay, you just moved it in the wrong direction. If you just give me an answer, it's harder. But with ones like this, there's not really a lot of work to be shown. So I typically just write the answer because I just do a lot of that in my head. So, 26 p cubed q squared all raised to the negative 1. Okay, well we still want to follow basic rules of like PEMDAS. So what do we typically deal with first? Okay, parentheses. So I want to deal with everything that's happening to this whole parentheses. So what's happening to this whole piece? Okay, yeah, these are not the same, so I can't add them. Okay, this is a P and a Q. Okay, but I want to deal with this negative 1 that's outside first. So what does that make everything do? Okay, I can, so I have two options here. So I can do what y'all are telling me to do and do p to the negative 3, q to the negative 2. But then am I done? Okay, I would have to then flip everything to the bottom. Okay, but from here, I could have just gone straight to, oh, this is negative 1, so I need to put this whole piece on the bottom. So I could have actually just gone 1 over p cubed q squared. Okay, and basically saved myself a step. So either way is fine. I just like saving myself steps if I can help it. Cool? Okay. Yeah, but we still have like 20-some minutes left. We're only doing a couple more. I'm just trying to get a good variety here. Okay. Just so we see, okay, similar to this one, we have, in parentheses, 5, s to the negative 2, t to the 4th, all raised to the negative 3. Okay. So, you have, again, you technically have two options here for what you can do, but my recommendation with one that has a lot of stuff going on and it's not just like, if these were just like 5st, I would say just write it as 1 over 5st cubed. And then I would go through and put the cubed on everything. But because these exponents are different, I would deal with this outer exponent going to each piece first and then like work on it, if that makes sense. So I would go this route with it, I guess is what I'm trying to say. Go this route first with one like this. Okay, and it's really going to kind of be up to you, but I'm just trying to tell you like how I think is like easier to think about it so you eliminate any mistakes that you might end up coming up with. So, if I go this route up here with it, what does that give me here? Yep. So just work your way across and then we'll move everything later. Okay, so I had 5 raised to the negative 3. I had s to the negative 2 times negative 3, which is what gave me the positive 6. And then I have t to the 4th times negative 3, which gave me the negative 12. So then now what do I need to do with it? Okay, so s to the 6 is staying on top, and then on the bottom, 5, that becomes 5 cubed, okay, which is 125. and then t to the 12 then on the bottom as well. Okay? No. Yes. Positive. So yeah, so the -3 here, that just moves it to the bottom. That doesn't like make the number negative or anything. Now, if the number started out as -5, then obviously yes it would, because you have, it's a odd power. But like you're saying if this was your original problem? Yes, you would, but you shouldn't get to that point. Like an original problem like this, because you would have added those exponents together to begin with. Let's look at the problem that I gave you really quick, and then we'll do one more after that. I'll have you guys try one more by yourself after we go over the one we did. Or I think, let's see, I think it was problem 36 from the book, which is 2x squared y over 6xy to the -1. Was that right? Okay. So, my goal is just for you to attempt it. It didn't have to be right. Okay, so then how would, based on the stuff we've talked about so far, how would I go about doing this one? Okay, so I have, so what does that do to my numbers? Yeah, so I just work my way across. I think it's the easiest way to do it, and you don't have to separate it. Like you can if you want to, that's fine, but if you have really big ones, you're probably not going to want to separate everything. So if you have, I mean, you can look at it still this way. So you have x squared over x, so I need to simplify that, so what's happening? Yeah, so basically, I mean, with something that's like 2 and 1, you kind of just know just to cancel it, but you can just, like, say it's x to the 1 on the bottom. So it's on the top, x to the 2 minus 1, which is just x by itself. So you have x on top, and then what's happening with the y's then? Y squared, yeah. So I'm going to add it to the top. Whoa. So that gives me y squared. So then technically it's xy squared over 3, which was technically option B, which I didn't give you options, but in your book it's option B in case you were. Okay, any questions about that one? Just 2 over 6 is 1/3. I added it to the top. Okay, one other problem really quick, and then I'm just going to give you guys problems to work on. 34, y to the 11 over 4z cubed times 8z to the 7 over y to the 7. Okay, it looks like a lot, but this would be a good time to use the method that Joelle was just talking about a minute ago, where you combine everything that goes together. Okay, we remember when we're multiplying fractions, okay, like you can multiply everything on top, multiply everything on bottom. So I'm going to try to group my numbers together. I'm going to try to group my y's together, and I'm going to try to group my z's together. I don't even know what I just did with this marker, but okay. So I have 8 over 4, okay, times y to the 11 over y to the 7. And then I have z to the 7 over z to the 3rd. Okay. Now, I don't typically rewrite it, but I think for just ease, it would be better to do it this way. So, then what happens to my numbers? Okay, so 8 over 4 is 2. 8 divided by 4 is 2. What's happening to my y's? Okay, so y to the 11 minus 7, and then z to the 4th. Okay, so z to the 7 minus 3 is z to the 4th. Because I don't have any negative exponents, and these numbers are smaller, so I'm moving them. You always want to move the smaller number, okay? Or if you have negative, you want to move the bigger negative, basically. Because if I had moved it the other way, they would be negative, and they would be on the bottom. Okay. Any questions about any of this? I feel like once you guys do some, like, more on your own, it'll also, like, make it easier, but... Alright, so then your problems... And like I said, 3 through 14, you're not following the exact instructions in the book. You're just solving it. You don't have to tell me. I mean, if you want to write the property, that's fine. I'm not going to take off for that, obviously, but you don't have to do that part. Also, what's any number raised to 0? 1. Okay. Okay, yeah. That's something that a lot of people, literally, I put a couple of those on my Algebra 1 test last year when I gave it to them, and no joke, I got every number under the sun but 1. Yeah, I was like, guys, I'm giving you a give me problem. If I ask you what 7 to the 0 is, that's like 12 free points. Let's see. 3, 13, 17, 19, 21. These should be relatively fast. That's why you have a couple, or more than usual. 27, 29, 31, and 35.